Welcome back. Today we're going to continue our conversation about 2-5. So what this means is we have the same learning targets. We're going to be learning how to write linear equations that model real-world data and make predictions from those models. Now, yesterday we were doing everything by hand, all right? We were making the scatter plots ourselves, sketching a trend line, and then using that to make predictions. Now, what I'm going to teach you today is how to use your TI-83 or TI-84 calculator to do that work for you. Okay, because we don't want to be doing all of this by hand all the time. The point is to kind of expedite that process, make it faster and more efficient. When you use the calculator, it can find the line of best fit for you. So the line of best fit is the most accurate trend line for a set of data. Basically what it does is it takes all of the differences between the actual data and the line that it's making and minimizes all of those differences. Now again, I'm not going to teach you the by hand to do that. That would be an insane amount of work. What I need you to know is how to do it on the calculator. And then find the correlation coefficient, which indicates the strength of the correlation. So those are the two things that we're going to get from this. So let's look at our first example. So our first example, you research the cost of movie tickets for recent years to look for trends. The table shows your data. So first, what is an equation for the trend or for the line of best fit? How accurate is your line? And then based on your linear model, how much would you expect to pay for a movie ticket in 2025? All right, now let's discuss how to do this with a calculator. So if you have one at home with you right now, this would be a great time. I want you to pull out your calculator so you're following along with me. You're much more liable to remember this if you're doing it with me. So, oh, and I'm sorry, I'm one step ahead of you already. So when you turn on your calculator, this is your home screen, all right? The screen that you find yourself at. Now, where I need you to be is in the stat menu. So right here where my cursor is, that is the stat menu. I want you to click that button and this menu should appear. When you get this menu, you're going to go into edit. And edit is going to take you into those lists that you just saw me start my screen on. So this is where you're going to put all of your data, all right? So looking back at our slides, all of these years right here, these are going to be your X's, and the average cost of tickets are going to be the Y's. So I want you to put your X's in list 1, oh, and your Y's in list 2. Now again, when we're talking about years, usually we don't want to put in actual years because that gets to be a lot of big numbers. So we're going to call 1995 year 0. So this would be year 2, 4, 6, 8, 10, 12. So those are what you'd be using instead of 1995, 1997, so on and so forth. So again, in your list 1, you're going to put the years. So the 0, 2, 4, 6, 8, 10, 12. In list 2, you're going to put those Y values, the average cost of tickets. So 4.35, 4.95, 5.06, 5.65, 6.03, 6.41, 6.88. When you're doing this, a really quick check to make sure that you've done it right is that the column should be the same length, all right? You need the same amount of data in both of them for this process to work, all right? Now, if you want to see your data graphically, all right, if that's your goal, is you just want to see what the scatter plot looks like, what you do is you go into stat plot, which again is right here where my cursor is. There's a stat plot, but notice that's the hidden feature. So you want to go into second y equals. That will take you into the scatter plot or into the stat plot. Go into the first one, turn it on by hitting enter, and then that first one right there is your scatter plot. And if you've done this right so far, the X list should already be list 1, The Y list should already be list 2, so you shouldn't have to mess with anything else. The only thing you should have to do now is go into Zoom, and then notice down in 9, Zoom Stat. This will automatically set an appropriate window for you so you can see the data well, all right? So again, big idea here, Zoom Stat will take you there. Now again, I'm going to show you this multiple times, so if you need to see that progression again, I will show you again. Now, so just from looking at this, we can see this is a very strong positive correlation, all right? But we want the actual numbers, all right? We want to see the actual equation, and that's something the calculator can give to me as well. Whenever you do a calculation, we're going to go back to the regular stat, and we're going to go over to that calc feature, all right? And in that calc feature, there's something called a linear regression. So if you hit that linear regression, and some of you have to hit enter a couple more times like I do, some of your calculators will take you straight to the equation of the line, but it's going to pop this out for you, all right? And so basically what this is giving you is the equation of the line. Y equals AX, so 0.218x, plus B, plus 4.26. So that's the equation of our line of best fit. It's done all that work for us. Now, the next thing I want to draw your attention to is this R value right here. R measures the correlation for us. Okay? When R is a positive value, it means it is a positive correlation. When it's a negative value, it's a negative correlation. And the closer it is to either 1 or -1, the stronger the correlation. So 0.997 approximately, that is a very, very strong correlation. So it's telling me this is a very strong positive correlation. Now, of course, we want to use our information to make a prediction. So let's see, I'm trying to remember, what year do we want to predict? We want to predict 2025. We want to predict what will those prices be, the average ticket cost, what will it be in 2005 or 2025? Well, from 1995, that's a 30-year difference. So X is going to be 30. And now the cool thing is, the calculator already gave us, oh, it's not negative, already gave us the equation of the line of best fit. So all we have to do is plug 30 in for X, and then it's going to tell us about 1080. By 2025, average ticket prices are going to be about 1080. Now, all the wordy stuff that's on this slide, that goes through the process that I just took you through. So if you ever forget a step to take, you can reflect back on those steps right there, and it'll take you through what I just did. However, if in following through it, you remember those 3 steps, well, then you don't necessarily have to read all of that. Again, it's just for your benefit if you get lost in the process. Now, let's take a look at these. So these tables list the cost of 2% and whole milk. Find the line of best fit for each. Based on your linear models, how much would you expect to pay for a gallon of each type of milk in 2025? And then again, let X represent 0, or let X equals 0 represent that first year of 1998. Again, we oftentimes do that with years so we don't get such big numbers. So we need to input our data here. So first, I'm going to input my data for the cost of 2% milk. So let's go through this process again. So turn on my calculator, boom, it takes me right here. First thing, go into stat. From stat, go into edit. Now this time we already have data here, and we don't necessarily want that data there. So I'm going to scroll up. So I'm highlighting the list itself, hit clear, exit downward, and it'll clear the list for you because I don't want the data anymore. So I'm going to clear both of my lists so I don't have anything there anymore. And now I'm going to input my data. So 0 is representing 1998. I have 0, 2, 4, 6, 8, 10 for my x values. My year is going to be my x. And then y values, I just type in those into list 2. So there is my data for the 2% milk. All right. And if I'd like, I can actually see that scatter plot. So if I want to see the scatter plot, go into stat plot, make sure it's on, make sure it's set to scatter plot, zoom 9 it, so it will fit it for you, and there's your scatter plot. So it's a good idea to see, but again, for line of best fit, you don't necessarily have to be doing that step. If all you're interested in is the line of best fit, well, the line of best fit is in stat. Scroll over to calculate and down to the linear regression. And again, sometimes you have to hit enter a couple times for it to actually calculate it for you, but there it is. So what is this telling me? Well, again, y equals ax plus b. So it's telling me my line of best fit, y equals ax plus b. So there is my equation for my line of best fit. And an R value of 0.9, that is still telling me that it is a relatively strong, definitely positive correlation. So you do always want to gain that data as well. All right, so that was for 2%. All right, so again, I hope you wrote that down for the 2% data. Now let's go, and we want to calculate the whole milk data. So I'm going to go back into stat, back into my list. Now in this case, my list for the years is exactly the same. So I'm not even going to clear out my list for the years. All I need are new y values because all the years are exactly the same. So now I go and I'm going to type in that data. 2.65, 2.89, 3.0, 3.01, 3.20, 3.77. And there's my data for whole milk. And again, if I wanted to see the scatter plot, I can go into stat plot, make sure my data is on, and scatter plot, zoom 9. Here's my information for whole milk, my scatter plot for the whole milk. Again, you don't really have to do that, but again, it's a good idea to see the data because you can already see it's positive and relatively strong. Now for the line of best fit, which is the most important piece of this lesson. For the line of best fit, go back to stat, over to calculate, and you want that linear regression. Hit enter until it shows it to you. And here it is. Y equals AX, so 0.093x plus B, so plus 0.620. So take a second to write that down. And then again, I want you to note your R value. So look, this R value is a little bit higher than the one for the 2% milk. So what that's telling me is my whole milk has a stronger relationship than the 2% milk because that R value is higher. So now the last step, we do want to be using these to make predictions. So again, we have both of our equations for the line of best fit. And then this one, we have this. And now we want to be making predictions from that. So 2025, that means 27 years have passed since 1998. So I'm going to be making predictions about 27 years in the future. So let's plug that in and see. So I'm getting about $5.06 for our 2% milk. And then for whole milk, I'm getting about $5.13 for the cost of whole milk. Again, just by plugging in that 27 for X to make that prediction. All right, so thank you so much for joining me for this. Now, don't worry, if you didn't have a graphing calculator with you at home, I will kind of show you this again during class when you can have one of mine or we're looking on with a friend to make sure that you have this down because this is a very, very important skill to have for Algebra 2, being able to take this data and find that line of best fit. But in the meantime, I would like you to please write your summary for me. Tell me what you've learned, some things you can reflect on from this lesson. So again, thank you for joining me. Fill that out and then come back ready to do your practice work.